in most of the cases, okay, like let's say in almost all the department has a UPS, uninterrupted power supply. Inside in UPS, okay, you will have a rectifier as well as the inverter. Now you must be thinking, why do you require a rectifier? Because try to understand this, okay, you need to convert AC into DC, okay, during the direct online connections. If you have a supply connected from the grid, then the battery has to be backup, has to be battery needs to be charged. And when there is no supply from the grid or from supply line, then this whatever the energy is stored in the battery, that has to be converted, means inverted back to the from DC to AC. That's why uninterrupted power supply has both AC, means rectifier as well as a inverter. And we have a hybrid system also. Almost all the department has an UPS. You might have seen in our computer lab, okay, lab, that we have a UPS. Now I just want to ask you, okay, KV, there are KV ratings, right, of our inverter, means of, let's say, the UPS, okay. Now how much load it can cater, okay, how do you calculate this? Suppose let's this 25 kV. If a inverter is, if a UPS is 25 kV, okay, how do you think, means how do you calculate the how much load it can cater? So these things are quite important for you to know that. Maybe later on when you pass out from here, you might be some your board, your immediate supervisor might ask you to find out the inverter which can cater the load of the particular office or a particular section. So what should be the rating of the UPS? That you should be knowing how to calculate this. And use all these calculations, okay, we are just studying all this theoretical part, okay. Practically what we are trying to do is, when you go to the field, okay, these are some of the things, okay, you might be asked by your supervisor or immediate boss to find out. If you are asked to find out the asked to buy an inverter, okay, means ask the UPS for your particular office or a particular area, then how do you find out that what should be the rating of the UPS, uninterrupted power supply? Because you require a backup supply, especially during the rainy season. There might be a disturbance on the power supply from the grid connections. So these are some of the things, okay, you should be knowing. And other one is a hybrid system. If you see in our AGM block, okay, we have a hybrid system. We have a charge controller, or okay, which is a hybrid. It is connected both to the solar panel as well as to the grid. So the battery can be charged from both the end. So if there is a bright sunshine, it will charge directly from the solar panel, photovoltaic cell. Then if there is some cloudy day, if the battery is going lower than what is expected to be, then it can directly charge from the grid connected system. So these are some of the hybrid systems which are practically used. So maybe later on, okay, if your office requires once you pass out from here, if you want to install a solar panel at the top rooftop, or you have a grid connected system, then if you need to have a system where both the system work simultaneously, then you need to know this. There are hybrid systems with both the inverters, means like charge controllers can work on the grid connected system as well as in photovoltaic cell PV systems. So this is what we will be doing in whole of our power electronic courses. The initially first one is just the power electronic devices. The other one is a DC to DC converter, which we have already done. Constant to variable DC, we have already seen this. There are the conversion labels, choppers, which are used from fixed DC to variable DC. Then DC to AC, which we are going to see in this one, inverters. DC to AC, a desired voltage and frequency level. At what frequency level are you going to have this? So based on this, we'll have the DC to AC converters. Then AC to DC converters, which we have already seen, that rectifier is also known as rectifier. Then AC to AC converter, also known as the psycho converters, of at what frequency and at what voltage level is desired to have at the output. So these are something which we are going to learn in this unit. In unit 4, we'll see the what is voltage source bridge inverters. Key voltage source bridge inverters, voltage control and harmonic reduction in inverters. Because when we are talking about converting a DC into AC or any conversion level, okay, from one form to another form, there will be a generation of harmonics, that unwanted signals. That these harmonics are unwanted signals. So you need to remove this, how to reduce the harmonics in inverter. But our main concern, we require to have a pure ST at the output. We don't require any harmonics at the output. So we have a current source inverter, voltage source inverters, key. Current source inverters, series inverter circuit, key. Then MC Mori inverter circuit. These are different type of inverter circuit. Three-phase bridge inverters, pulse width modulated inverters. So how do we, what is the operation? How does it works on pulse width modulation inverters? Voltage control in inverter. How to control the voltage in the inverters? Key. So these are some of the things which we are going to learn in this unit, particular unit. Okay. Now inverters. Okay, you might have come across these terms inverters. Okay, in so many places. Okay, that in maybe in previous modules. Okay, this inverters is a process of converting a DC power to an AC power at a desired output voltage and frequency. So what should be the line frequency is, let's say 50 hertz. The supply frequency is 50 hertz. But if your system is working at 150 hertz, then you need to have output with desired output. Let's say the output voltage is around 200 volt and the frequency is 150 hertz. So you have a provision. There are provisions in inverter where you can convert at a particular frequency level and at particular voltage. So that is based on your requirement. So this can be done by fully controlled converter. So converting from one form to from DC to AC at a desired output voltage and frequency, this is done by the controlled converter using a thyristor connected to the AC main. Means, so this can be done with the help of controlled converters. Means you have a fully controlled converters. Means that you have control over this converters, and this by using a thyristors. So thyristors can be useful. In some cases, we can use SCR. In some cases, we can use even power BJT, power MOSFET, IGBT. So there are different type of power electronic devices. So this is called a line commutated inverter. Now, this line commutated inverter, so what does it mean? That the controlling mechanism can be possible when it is directly connected to the grid or a line. And the power can be controlled at the output of the inverters. Means that controlling mechanisms are from the grid or from the line. So means like it can be with line commutated inverter and operates at the line frequency only. Means it's operating at the line frequency only. Means that the controlling mechanisms are possible based on the line commutations. So when the thyristor based inverter supplies an AC power to an isolated load, key. So when the thyristor based inverter is supplied an AC power to an isolated, suppose if you are supplying to the isolated load, it's not connected to a grid, it's not connected to your system, is in isolation mode, then force commutation techniques are required in this case. But in previous case, if you are connected to a grid, okay, and in based on that, means commutations are line commutated inverter. But in case of isolation mode, then the force commutation techniques are required, which means the inverters are bulkier and costlier. So in this case, the inverters becomes bigger in size and it becomes quite costly if it is working on the isolation mode. Now, as I have been talking about, our hydropower systems are really suffering in the isolation mode. When they were testing this Mangdisu, okay, when they were commissioning this Mangdisu, they were trying to run our systems in isolation mode. They were not successful in this, even in the Mangdisu cases also, because when the loads, when there is a changes in the load, when there is a variation in the load, there is a grid, there is a failure in the grid, whole grids are collapsing. So it's really, there are so many things to have to be studied on this, how to the how the hydropower, how the systems are working in the isolation mode. When you are connecting, you try to interconnect the systems. When the two generating stations are interconnected to a grid, when the two generating stations are connected to a particular grid, then what are the, means what are the features you need to fulfill when you are connected, when you are synchronizing with the grid. So there are so many norms we have to based on the grid code regulations of Bhutan. So based on this, in this particular cases, if you are working, if you are trying to use an inverter, thyristor based inverters in isolation, isolated load, if it's connected to the isolated load, then the force commutation techniques are required in this one, and it becomes really costly and become bulkier and costlier. So thyristor based inverters use only for the high power applications. If you are using for the high power applications, then only we can use a thyristor based inverter. Now I just want to ask you one thing, okay? This is me, this is something, okay, related to this. What happens when you connect a UPS to an inductive load? Because most of the UPS, uninterrupted power supplies, are UPS are connected to the power circuit where we can use a computer or a projectors, okay, but we are not connecting to the AC, even in the in the ceiling fan. Or what must be the reason why you are not connecting? We are just using a resistive load only. We are not connecting to the inductive load. Any one of you, can you answer? Why you are
Question
connecting?
hamago sir.
Question is, why you should not connect a UPS, uninterrupted power supply? What will be the problem? Okay, if you connect the UPS, okay, this is just a backup supply, right? Why we should not connect to the inductive load? Kachive, why we should not connect? Means what will be the effect on overall system, means performance of the system, if we connect to the inductive load? Till now we have been talking about what is the effect of the inductive load, right? If we have a purely resistive load, if you have a RL load, what will be the effect, right? Now I'm just asking you the overall question, that what is the effect the of the performance of the uninterrupted power supply if you are connected to, if the load is an inductive load?
Sir,
It
the
will
voltage drop
deliver
from the
all of
UPS will
its
be more, no,
kilowatt.
sir.
No, sir.
Okay, wait. Now I think first Chetan, then next loaded. Okay, let's see one by one.
So maybe this power drawn from this UPS will be more, no, sir, because in inductive load there will be resistive plus inductive, no, sir. So
Yes.
it will draw more, I guess, like this.
Yes, Karma.
Yes, the same, sir. It will draw more of its kilowatt rating. No, sir. All of its rating will be drawn, sir, from this UPS, sir.
Now you must, I'll ask in different way. Okay, if the load is inductive, okay, you are asked to have a capacitor bank, right? Most of the industries are, they should have a capacitor bank, okay, if your load is inductive in nature. Let's say a furnace, okay, or let's say Bifal Bhutan Ferroalloy Limited, okay, that they have a furnace, okay, which load is an inductive load. Now you're asked to install should have a capacitor bank, right? What is the function of this capacitor bank?
To supply
And for bringing leading power factor, no, sir.
reactive.
for better efficiency, sir. To supply
What happens
reactive
to the
power.
power factor if the what happens to the power factor, okay, if the load is inductive in nature?
Lag.
Current will lag the voltage, no sir.
Yes. Then what will be the effect on the in terms of a supplier or a distribution point of view, and in terms of
This,
customer
current
point of
consumption will be more, and this the overall this the energy required will be more, no sir. In inductive load, in inductive load.
Inductive voltage will lag due to magnetic field, sir.
Inductive na the voltage lead bhi hoंगे ना, current lag bhi होंगे ना.
view? Okay. Kezang Sodin, what is your opinion?
No idea, sir.
No idea. Tenji Jamso? Now, what will be your recommendation? Suppose if you are working in a distribution company, okay. Now, if the consumers is having an inductive load, okay, if they do not comply that, they have to have a power factor. They have to maintain the power factor between 8.5 to 9, right? Let's say 8.5 to 9, okay, between that. So if they do not comply with this, then what will be the measures that as a distribution company you will take to that particular company?
Sir, basically this power factor is equal to kVA divided by kilowatt, no, kVA divided by kilowatt, no sir. Kilowatt divided by kVA, sir.
Yes.
So if we PF is equal to apparent power, kVA divided by this one, sir.
Company will
So-
charge them more higher, sir. I think
So
and power factor is
can
high and low.
we can compare, no sir, because if in case the power factor is low, then this kVA demand will be much more higher, no sir.
Okay. Now there are ways, okay, because it affects both the in terms of a consumer point of view, in terms of a distribution, because there will be effect on a distribution point, means as a means like distribution company also. So these things are there. You might have studied in the power systems or in generation and tasks. I think it's there. I think some in power system related courses. So I was just trying to see, okay, how much it, because when we talk about all these things, okay, that converting from one form to another form, okay, when we try to see these things, okay, that you're trying to convert, and it depends on the load, okay, type of load it is connected to, and your main desired output should be a pure AC. So there should not be any harmonic content on that pure AC system, means conversion from one. So for the low and medium like power inverters, okay, gate control turn off devices are used. So means like these are some of the gate controlled, okay, power turn off devices, like gate communication devices, like such as power BJT, okay, MOSFET, IGBT, GTO, SIT, and all these are, there are so many other devices also, which is also known as the gate commuted devices, okay. These are used for the low and medium power inverters, okay, but for high power inverters they use mostly they use the STR silicon control rectifier. So in addition to being fully controlled, this have a high switching frequency. So you know that which devices is having a higher switching frequency. If you try to talk just above whatever is shown there, okay, power BJT, MOSFET, IG means comparing among this IGBT is having a most means higher switching frequencies, means like which can be that the switching frequencies are quite high, I think, on this IGBT. So these are some of the applications: the variable speed AC motor drives, induction heating, standby power supplies, okay, high voltage DC transmission systems. So where we use these systems, means like DC to AC converter. If you might study this, okay, the high voltage DC transmission system, okay, that in HVDC systems, these converters are really important, because in high voltage DC transmission systems, okay, first you have the generation is in AC, okay, that has to be converted into DC. Then you are transmitting that in DC, okay, to the receiving end. So you are converting that AC into DC, and you have a DC transmission line, and at the receiving end again you have to convert that DC back to AC. So this conversion is quite important in case of a DC transmission system, and there are advantages and disadvantages of this. Because of the advancement in the power electronic devices, okay, people in some part of the world, okay, people try to transmit the power in DC, in a high voltage DC transmission systems. There are advantages, also disadvantages. I know you will study this in some other modules about this. I think it's there in a application of power electronics application. Some of your friends, those who are studying application of power electronics system, power electronics, you will study that what's the advantage, different type of HVDC systems, and the advantage of using this HVDC system. Now I think I'll stop here. Okay, today's class will continue from in the next class. And what I'm thinking is I'm just giving you, okay, we have to do the face test. So face test is what I'm thinking we'll do for first, second, and third unit. Is it okay?
Okay,
Three-
sir.
Three
Yes,
units.
sir.
First, that power electronics devices. Second is rectifier, right? The third unit is chopper. So we'll stick to this 3 unit. Okay, for the face test. But we'll let you know when you will be the your face test and other information. Okay.
Sir, so the face test is confirmed. Then what about the exam in this also?
Now, okay, what we cannot say anything, okay, but till now the information is that we have to do till face test now. Face test should be done. Should have to be, means we have to do the face test. But I don't think that it will be possible to do the end semester exam, because face test is just a 10% only, right? So we can devise a way to assist the student in different way for the face test. But if we are talking about the semester end exam, then practical components are not fulfilled. Even if we do semester end exam, okay, but it will be really challenging. I don't think that the university will ask us to do the semester end exam, but online. But if you have to be prepared, okay, if the college opens and you have to come back to the college, I don't think that we are going to repeat whatever is taught to you online. So we are asked to